So let me check if it is live. Yeah, so recording is ongoing and the audio is also ongoing. Okay, good. So let's then start. And yeah, first of all, why we are talking about object-oriented programming. During the previous sessions, I mentioned such term called abstraction. So basically, when we are writing the code, when we try to, so we usually try to use the abstraction. It can be actually done in different ways. Previously, we defined the methods. We defined the methods to basically have the behavior of the program in one section of code, and then we hide it in the separate method, which is described which is called the name, which is named in the way that we do understand what does this method do, and then we call it from some place in our code. So basically, when we call this method, we see the name, we provide the necessary parameters, and we usually don't really care about, don't spend the time watching the code, see what happens inside this method. We simply call it and get what we need, what we want from it. This is the part of the abstraction. In fact, we can make this abstraction it means that actually, I usually say that we don't care about what's going on with these particular methods we call. But the idea is that in general, the abstraction means that we don't see the direct way what do we use. We simply take the piece of code. We simply have the method name, and we may have also the objects. We'll talk about them, the classes, the objects, and then we simply use in general. By default, even without defining our own methods, even just basically use some basic things what we have in C# and .NET. Even you see, we have the class. Even with this, the most simple program, Hello World, we have the abstraction. We use the abstraction, and this is the here you see it's the system class. Right? That's the library system. And basically here we use the class console. So that's the class console, and we can use several methods. We use the method writeLine, readLine, parsing, and so on and so on. So we use lots of different classes and methods and objects, and so it means that we already at the beginning of our programming, even with the most simple tasks, we already use the abstraction. Because again, as I said, we use such things like the methods. So I don't see how this method is defined, and you also don't see it, and maybe you also don't care about it. So I just basically see that writeLine, I provide the parameters, and it works for me. I don't need anything more, right? So the same is with other parameters and methods, and basically also the same would be when you write your own code, and it's then used by someone else. So, and this is what the abstraction is about. We try to as I said, we try to hide, but the most important would be that we try to group our code or someone else's code in the place which can be, first of all, it can be accessible when needed. Yeah, of course, we can make some pieces of code to not be accessible in one or another way, but that would be maybe different topic. So we need to group the piece of code when it can be accessible, when it, of course, where it is understandable. Yeah, what does this code do and how to use it. Yeah. So yeah, this is the general concept of abstraction. Yeah. So, and by default, that's the process of defining essential concepts while ignoring the non-essential details. Yes. So, as I said, the important concepts for us, the important thing for us is that we have the method name, we can provide the parameters, and we ignore how actually this method, this class, this library is constructed, how it is built. I'm the user, and this is what I want to do. Yeah, so that's from my point of view when we understand the abstraction and when we use it. I mean, this from my point of view, this will be the main, say the main step between maybe the beginner programmer and more advanced programmer who first of all, yeah. So in this case, I mean, when you don't care about the abstraction, so it means that you care almost about everything, how it's going, how the program works, what needs to be done, what are the smallest details of the program, how basically everything works. Then yeah, like that's, I would say, maybe more about the engineering process, but I mean, on practice, usually, what's the task for the programmers? Usually, what is the task for programmers on practice? It's not like the programmers need to understand everything. The programmers need to go deep inside, I would say, almost everything, because in most cases it is not needed. Since again, as we had a discussion in previous sessions, we talked about. So what did we talk about? Yeah, actually, I don't remember the exact topic, but we concluded that in the newest frameworks, in the newest, in the most recent frameworks, systems, applications, there are they are built in the way that we don't need to we don't need to go deep. We don't need to know everything. We just simply need to take what we have and simply be able to use it. So this is what the programming is about. Because nowadays, again, as I said, we have lots of different frameworks, lots of different applications we can use, lots of different code examples we can use, so packages, libraries, and so on and so on. So and yeah, basically the key point, I mean, the key point for the programming nowadays is not that you can write the code, you can understand the code, but that you can use what is provided. Yeah, because I think you will maybe almost never do anything from scratch. Yeah, of course, it's maybe if there's your private project or some special cases, then yeah, then you may build the application from scratch. But I would say in usual cases, the key your key advantage would be if you make if you can use what is provided. So if you can use the frameworks, you can use the existing solution, you can understand the existing solution to be able to configure it, to make some changes there. So this is the point, and this is also about the abstraction. Since again, also currently with .NET we're working with framework, then lots of different libraries, and what we need to do, we need to use them. we need to be able to use them, to understand how to use them. And this is what the abstraction is about. And yeah, this is what it is about. So what kind of abstraction can be? So first of all, as I said, in general, but if we talk about it in more precise direction, then it can be data abstraction. So it means that we don't care about, not don't care about, but we don't follow it sometimes. Yeah, what are the properties of the exact data, of the exact yeah, later on see the object. Yeah, for example, when we run the simple program, any simple program, we run the program, but as you already understood it yesterday and even before that, we have some system parameters, yeah, some technical parameters used during the program. So I mean, all the parameters, these are all the data, right? So it's all the information, time, some technical details, memory available, and all such things. They are also the data, right? And here, what happens again? We don't. I mean, so you don't check what is all this data, how it looks like, and basically what is there. It is used by a system, it is used by your program, but you don't see them. You don't see them, and so they are not important to you. They are important for the program, but it's not for you as for the programmer. So yeah, this is the first point. The second point is the functional abstraction. So it means these are the actions. The actions done again in this example by the system methods. So here we have the right one, then we can have parse, and as I said, any other method what we can call, and we are the users of these methods. We use them, and we don't go deep. Also, lots of different other processes happening during the execution of our program, but they are not important for us, so we don't see them. Yeah, we wrap them, and I mean they're wrapped, and we don't access them directly. So, and basically the third point is the object abstraction. So it means that we can during the execution of our program, we can create the separate unit for I mean based on some template, and then this unit can be basically we can drop the data and the functionality inside this particular unit, and this is where the object-oriented programming comes, and where we can use it. So yeah, first of all about the objects. Similar as in real life, in the same way we need to think about them in programming, and basically this is why they are called the objects. Yeah, so it means that something what has any parameters, it has the data, like book has the pages, yeah, the data, like we can say that's collection of pages, where the pages can be stored, and each page is actually also the object itself. Each page actually is we can say that it has the same template, it has the same structure, but they all have different content, right, for the pages of the book. So the same as with the object. Yeah. So then also the car, it has maybe not only the data, but the components. Yeah, for the objects, the data and components, I would say they are the same. These are the same things. So for the car, we have wheels, doors, and so on. Then computer. Yeah, so the most obvious example of the object and what can be described and also the building, and all these objects, they have the functionality, they have the behavior. It is not mandatory that each object has the functionality, even if it's not mandatory that each object has the data. In fact, yeah, maybe we can go see it a little bit later. There are also, we call them the marker. There can be marker interfaces, or marker also can be marker classes, which basically are the classes. So we create the class and do not assign any parameter or any method to this class. And these classes or interfaces, in this case, it doesn't matter. They are called as the marker interfaces, marker classes. It means that I mean, they are created. They are just simply empty interface, empty classes. But later on, they can be used for the other classes to, like we can use the inheritance option for the other classes, and then we can actually assign this this mark, yeah, this property, actually not property, but only we can mark other classes, other interfaces using them. But yeah, this is the special point. But here the main thing is that also the empty space without any data, without any functionality, can also be the object. Yeah. So the only thing what we need is the special, like from technically, you need to have a special address to the memory, which then stores this object. Yeah. And again, as I just said, it can be just empty object without any parameters or any functionality inside. But yeah, on the other hand, since we talk about C#, then even the empty object, everything is inherited from the class object. So it means that at least some you can say generic parameters will definitely be there. Some more people are joining. Okay. So yeah, do you have any questions so far? So is it clear what the abstraction is in programming? Okay, I hope that means yes. If not yet, please ask the question. So yeah, and let's move on. And the first thing is that we are defining the object. What we are defining the object, and what should we do from the programming perspective. So yeah, so object, as I just said, objects are the key part of object-oriented programming. That this is why it is called object-oriented programming. And the thing is that the objects can interact with each other. It says using messages, using the we can say using messages, but I would say also using the attributes and behavior. So each object has its own attributes and behavior. So it means that for the attributes, these are the variables defined globally inside the class, yeah, and they belong to the object. So when we talk about object-oriented programming, I will use the terms and descriptions in the way that the instance attributes and the object attributes, they belong to the object, and also the behaviors, the methods. And I would say that the static attributes and methods, they belong to the class. Yeah? So in this case, I say that the attributes and the methods of the objects, they belong to the objects, yeah? not to the class. They are defined in the classes, but physically they are stored under the object. So the information, we can store the information about the object. We must know the identity, uniqueness, like many different attributes. Also the state of the object, yeah, maybe that can be something that can be active or inactive, so it depends. And the behavior, the methods, yeah, so what we can call, and the events, yeah, also the special, as I would say, a special case of the methods. Yeah, we'll maybe talk about them a little bit later. So yeah, then the key, I would say, the key definition of the abstraction, how we can define it in the programming in C# is a class. Yeah, so using the class, we can define the abstraction for our program. So yeah, this means that inside the class we can hide and we can wrap, I would say, yeah, maybe not hide, but wrap the necessary parameters and the necessary methods. Yeah. So again, instead of writing everything down inside one program, we can split it into the multiple objects, group them into multiple objects, and this will make this usually makes the code smaller and more readable. Yeah. So again, the simplest would be, let's say that you want to create a program which creates, let's say, maybe five persons. I mean, the data of 5 persons. So in this case, you would need to then like maybe repeat the same code 5 times. Yeah. So on the other hand, you can wrap everything inside the object. So you will group all these elements into the objects, and then they will be stored. So you will have the situation when they will be wrapped, yeah, will be wrapped inside their objects, and also then the behavior will be defined separately in the classes. So yeah, then we have the class, and then in this case we see that it describes three objects. It has 3 instances of the corresponding class person. So the name, yeah, so what we can assign as the property, the name of the person, the age of the person, and then each person can tell name and tell age, for example, and the simple behavior. One more point, you remember what I told you yesterday, how the instance, yeah, so objects are, as I just mentioned, they are the instances of the class. Yeah, so they are instance I actually use instance references as synonyms. So these are the objects are the reference variables. Yeah, so, and this means that actually when we have any reference variable, it does not store name, age. Like in this case, if we say that we have the reference variable which stores the person as the object, then again the variable does not store the name, age. And these 2 methods, the variable stores the reference to this guy, and then this person. So that's the reference in the memory. So once these objects are created, then they are created in memory, and they have now the references to the memory and to the exact place in the memory, and then they are we can access the reference from the variable, and then use so-called the referencing and access these attributes. So the variable stores the address to the memory where these objects are located, and yeah, only there are these values of these attributes. Okay, so that is about the class. So yeah, then defining the classes. So we say that the class it's partially the templates from which an instance of an object is created. And so I would say, yeah, it's definitely the class can be used as the template, but it's not mandatory that it is only the template. Since we can actually use the classes without the objects, this is the usual and normal case. But yeah, so since now we talk about object-oriented programming, we take a look on the case when the class is the template for the object. Yeah, so it means that the class itself defines the parameters which are defined under the which will be defined for the particular objects, and then the objects actually fill in these parameters. Yeah. So yeah, it specifies the structure of data and the methods as the behaviors what we then use to build the object. Yeah, so the class mode is a model or template. Yeah, so I would say the model more precise that can be instantiated to create objects with common definition, therefore common properties, operations, and behavior. So it means that we have one class person, but then multiple objects are created from this template. And so we have one class person, but they all belong to this class. Yeah, and regarding the terms, there are multiple terms what we can use, and what I usually use. So we have the instances of the class. Yeah, so this is what I prefer to say. Like, I mean, when we create the object, we create the instance of the exact class. Yeah, so here we create the instance of the class person. So we can also call, they all have the reference. Yeah, so sometimes I can use term reference, yeah, instances, objects, and references, but yeah, reference always maybe more technical. But yeah, so these terms are then used. So yeah, in how do we define the class in C# and I would say in all the other languages, C++, Java, and similar, the definition would be the same. We have the class, name of the class, yeah, so we should have a name, and then we can define the methods and the attributes and the methods. And basically for object-oriented programming, these two are the key, and the majority is built based, majority of the functionality is built on that. Usually we define the properties on the top. In theory, we can define somewhere in the middle or even at the end. But yeah, the normal approach would be that they are defined on the top of the class, and we can also we can name them differently. I mean, using I mean, the terms can be different. I prefer calling them global variables, so it means that they are stored globally under the object. Yeah, we can also call them object attributes. Yeah, that would be fine as well. So yeah, I mean, the definition of them is done in absolutely the same way as we do it in the methods, but we have some more rules. First of all, regarding the initialization, we can initialize them, or needed we can skip initializing them. It's up to us. So it means that one statement can be done, but you cannot write the logic under the class. Yeah. So remember, you can only I mean, like create if statement, write if statements, switch statements, or something similar. So everything which is out of scope of the definition of the variables, you cannot write it under the class. Yeah, so like this statement, you cannot write it under the class. Yeah, you can only write them under the methods. Yeah, so under the class, only definition of the elements of the class. Yeah, you cannot write any logic, I mean, such logic which defines actually the behavior inside the class, only under the methods. So please be careful and follow the blocks of code. So yeah, and then you have the methods. We recently talked about them. So yeah, using the classes, we can define the template. Also, as I said, we can mark the objects and we can categorize them. So we can say that the name of the class is animal, then we can categorize animals. So then, actually, all the possible we can categorize them using all the possible categories. Yeah, so it acts as a blueprint, so it means that all the necessary structural definitions should be defined under the class. So yeah. Okay, do you have any questions? Okay, let's then move on. Then we have the class members, or as I name them, sometimes global variables. So they are two I would say absolutely different ways of absolute opposite ways of definition of the variables and methods. So they are there are static and there are instance variables. So what does it mean? It means that, as I just said, and what I also like to use, that the static methods and attributes, as I just said, they belong to the class. Yeah, so it means that they cannot be, like, if you have the class to a static, that this particular method, yeah, so let's say in count, I'm not sure his name, just simply in count, so let's go this way. Yeah, so means that for inside the code, inside any place in the code where this particular class test static is used, and you call the method in count, it will always have this logic. So that's a really important thing to understand, because later on we'll use the inheritance, abstraction, abstract methods, abstract classes, and then the case, you'll see that the case may be different. But yeah, so for the static in count, this logic will always be called from any place inside our code. It cannot be different anywhere. But what about array? First of all, array cannot be called from the static class directly, since this is what I said. It belongs to the object, not to the class, so it means that it cannot be used from the class. It can only be used from the object created from this class. Sorry. And comparing to the static method, this when you have like any random object inside your code, I mean not random object, but if you have multiple objects inside your code, then it is not mandatory. Then when you call the method area, then it will have this particular method, this particular logic. Yeah. So this is important. This is important. I mean, if the object has the class testStatic exactly with this class, then this object will be called. But in some cases, we may say that there is the object with the type testStatic. I mean, we create the variable, we have the variable, we type the variable as testStatic, and then we call the method. I mean, at some point we assign the object to this variable and we call the method area. Then it may have different logic. Yeah, it may have not exactly. It will have this logic. This is about the inheritance, about the abstract classes and methods. But yeah, please note and please remember what I say. The instance objects, the instance methods, their behavior depends on the object. Yeah, so for multiple objects, this behavior can be different. This is why I say that the instance methods, they belong to the objects, not to the class. That's the point. That's the point. So yeah, so the first point is that to call the instance methods, you need to create the instance of the class, create the object first, right? So yeah, do you have any questions? Okay, hope it's understandable. So the next thing, and it's an important thing, the constructors of the class. Actually, yeah, it is called class constructor. Maybe more precise would be the object constructor, the constructor of the object. So these are the method. Yeah, I'll say these are the methods. One of the methods. Yeah, which should be called. No, sorry, not one of the methods, but one of the constructors will be called when the object is created. Yeah, so it means that this is the initial logic with the initial parameters provided to the class. So the class, so the object can be created from the class. And yeah, so it means that every time when you create the object, then one of the constructors will be called, and there can be multiple constructors. Actually, they are overridden. Yes, so there is sorry, not overridden, overloaded, and so not mix these two terms. They are overloaded, so it means that we may define the several constructors, but with the different pattern of the parameters. Yeah. So and yeah, then based on like what is the overloading, we will most likely already know, but we'll later on talk about it. So the idea is that based on the parameters we provide, then the corresponding constructor will be called. So for the constructor, the name of the constructor should be the name of the class. So you cannot create the methods which are named in the same way as the class is named, and because it is reserved for the constructors. Okay. Yeah, so there, maybe you have the questions about this line. In fact, this line is not needed, but this one is actually works automatically. So in case we have parameterized and we have non-parameterized constructors. So by default, all the classes have the constructors. Okay. All the classes have the constructors, but I mean, if the constructor is not redefined, then it is just empty constructor. Yeah, it's public. Like in this case, it's private, but normally by default, the constructor is public. Constructor was without any parameters and without any logic defined inside the method. Yeah. And when we create parameterized constructors, by default, what happens? Yeah, maybe let's create this plus person. Why not? So just to show the directly in Visual Studio then. To do with big console application, I will add to the same solution, so I will. So yeah, I will do it in the way that I will use the same solution for all the sessions, but then I will create different projects. Then again, so then that will be demo 21. Okay. So and then let me maybe paste this class. Can I do it? Oh, sorry, that was not the class. That's right. Yeah, by the way, you can create the classes in the separate files, and you can also create them in one file, but please note that, as I said yesterday, you have the console application that only one of the classes can have main method inside. So because it's used as the runner method, and if you have multiple classes with this method, then the program will not understand actually what are you going to run. So yeah, then let's say that we want to create, so say that we want to create a class person, the object person, sorry, person, and let's say that we want to create person. You'll see that it should not be possible, because actually I think we don't need this one for now, since it makes nothing. But yeah, so if we redefined the constructors, and now our constructors now we have only parameterized constructors, then we cannot create the object without any parameters provided. Yeah. By default, if we don't have the parameterized constructors, then it should be fine. Yeah? Then that's fine. But if at least one parameterized constructor is defined, the person, we cannot create the object without any parameters anymore. So this is the first thing. And basically what happens? So you see there is this line of code again, which means nothing, because basically this is done by default when the constructor is one moment. Yeah, actually this is very interesting. Because maybe I will explain it a little bit later, but what we can actually do, can find one more method, and in this case that would be possible to person. Yeah, at this point, actually there is one difference. Yeah, there will be one difference. If we do define this, if we do define, or if we don't define this, this line of code. Maybe I can describe it to you. We'll maybe talk about it a little bit later. But basically, what happens here? Here I have the private constructor. So what the private and protected constructors mean in programming? They basically mean that that if the constructor is defined, the corresponding constructor is defined as private, or let's say if it's defined as private, then it means that I can only create the instance of this particular object. So it means that I can use this constructor only from inside the class. Yeah, so you see that I created the static method. I'm currently located inside the class person, and only inside this method I can create the object person. Yeah, so in theory, not only in this method, in theory I can create more methods inside this class. We can create any method inside this class and create the object person without any parameters provided, because I have this private constructor, and then I can create the person without parameters provided. But let's say that I comment out these two constructors. So based on what I just said, what will is there any way that we can create the object of the person outside of the person class, outside the class person now? So the question 2, is it possible now? Like we create directly, we create the class person, parameterized, not parameterized way outside the class person. It will not be possible. It will not be possible because the constructor is defined as private. So this is the one of the properties of the constructors. If we redefine the constructor and we define it as private, then we cannot create the instance of the class person from outside the class. Yeah, so this is such interesting property. One moment. So yeah, we cannot do it. We cannot do it, even if we provide parameters. Right now, we can do it by providing the parameters, and we can do it if we use the method inside the class. And basically, what the method, like in this case, you see the pattern, what I created. Such pattern such patterns are called the factory methods. So what does it mean? It means that there is the method inside the class which creates new objects. Yeah, so this is why it's called factory method. It produces the object. So the same is here. I created the method get instance, so it gets the instance of the person class. Yeah, and this is basically the way how we can work with the private and protected constructors. Yeah, we cannot create the objects from outside the class, but we can create the objects inside the class, and that's why we can use factory methods. Yeah, maybe I can also comment that it is factory methods, and yeah, then we can use it. Then we can use it. Why do we need it, and why we may need it? There are really different patterns of the program. It's very different ways how the object needs to be constructed. So, for example, there may be such case when, as I said, we don't want the object to be created from outside the class. Yeah, so like we don't want the object to be created from any possible point of the program. Yeah, so we want to restrict such possibility to create the object. So in such cases, we may use the factory methods, which are, I would say, are more flexible than the constructors, because what happens with the constructors? Every time we create the object, yeah, we call the operator new, yeah. So basically, what happens? Remember, operator new, it creates new object. Yeah, basically, it calls the constructor, and actually this operation it returns the object trans. So basically, you see that every time when the constructor is executed, despite the parameters we provide, despite any factors, the object will always be created. Yeah. So in this case, it's not possible that you call this method and then it returns nothing. Sorry, not method. You call this operator, you call the constructor, then it returns you nothing. It's not possible. It's not possible. It will always return you the instance of the person. However, yeah, there is the possibility that it will raise some exceptions, or there may be other errors inside. But I mean, if there are no exceptions and errors, then the constructor will always construct you the object when you call it. Yeah, comparing to the instance method, comparing to the factory methods, which can have a situation where there is nothing returned from them. Yeah, so this may be the point, but we'll maybe talk about the factory methods a little bit later. So for now, just to understand that if we have the constructors, then sometimes constructors may be defined as private or protected, and then the access to the object creation will be restricted. Right? Do you have any questions about what I just described now?
Maybe about these factory methods.
Yeah.
So where and why they are used in practice?
Yeah, as I said, we may need to. First of all, we may need to restrict the ability to create the instances of the class. Yeah, for example, at this point, when I have only the factory method and I have the private constructor, and let's say I don't have these parameterized constructors, so let's say I comment out, that means that I cannot create the object of the person class directly from anywhere outside the class. Yeah, so I directly point that I cannot do it. So, and why it may be needed on practice, there may be different reasons. For example, if there are large programs, then maybe, for example, some authorization checks. For example, this get instance program will check the authorizations and maybe will not allow you to create the instance. There may be some needs for this, but I would say that the most important would be that this get instance method. Yeah, this will be more about the inheritance. So when we talk about the inheritance, and maybe I'll talk a little bit ahead. We know that we can do the casting. We can cast all the subclass objects to the parent class. So at this point we have the variable, which is tagged as person. But what does it mean? That this variable can also store all the objects created from the subclasses of the class person. Yeah, so they all can be casted to this. When we call the constructor new person, then it will only return the objects with type with the class person. But at some cases, let's say that if we have the abstract class or something like that, then we may need to have the situation when not the class person will be, not the object with the class person will be returned, but the object was the subclass of the class person to be returned. Yeah, so there may be some enhancing functionality. I guess I have one example what I wrote in Java. I'll maybe show you after the break. But yeah, I guess I have such code, and I'll maybe show you after the break. You'll understand that it's quite similar to C#, and the idea there is that instead of returning the person, I have the option to return the object from the subclass of this class. Yeah, like for example, let's say that you have the class file. Yeah, you have the class file. Then for example, you want to create the object from the file. Yeah, and then actually you have the file types. Like let's say that you have the XML file, Excel file, Word file. Like imagine any file type. Yeah, so let's say that currently we can work with three file types. That would be XML, that would be CSV, and that would be so XML, CSV, and JSON
PDF.
files. Yeah, like three different file types, for example. And yeah, we have the class file. So again, the object file, you can imagine what does it mean. Yeah, you have the object you have the file as the object. And but in fact, you have the program which does not work with the file with the object file, but it works with the subclasses of this class, which is again, as I said, XML, JSON, and CSV, for example. So we want then to return we want to construct the object. And then let's say that we have get instance, and we can also provide some parameters. For example, I want to provide a parameter name. Yes, so for the file, that would be file name, for example. So I have the program which actually returns me the instance of the file. Yeah, get file, but the instance can be, again, it can have the type XML, CSV, and JSON. Yeah, so in this case, I would provide file type, and then I will, for example, I check the extension, or I read the file itself, then I check what's the file type, and then I return not the file, but I return CSV, the object CSV, I return the object JSON, or I return the object XML. Yeah, I will show. I have this example in Java. It is quite similar to what we can write in C#, but that's the point. Yeah. So again, comparing to the similar constructors, we can only return, like we have, let's say, a little bit limited functionality. We can only return the object person. Yeah, but so let's say that if I have the situation when I need to return the object of the subclass, and in this case I can use factory methods, which again, they do more advanced functionality comparing to the constructors. They are similar what we can do with the constructors, but they have a little bit advanced functionality. I will show you maybe a small example after the break. Yeah. So then you will hope you may understand it better. Okay, so let's see. I mean, during the break, you can prepare also other questions if you want, and then let's have 10 minutes break and see them at 7:41. Okay. All right, so let's continue. So you see, yeah, this example from Java, but the concept is absolutely the same as we can write the same in C# as well. So we have 4 classes. Each class represents one file type. Yeah. I mean, I had a special. It was on task when I had to implement some special parsing, special reading of the files provided based on the file type. And the file type could be different. It could be CSV, JSON, or XML. And then I had to provide the file path to the program. Then the program had to determine the file type and then execute the corresponding logic based on the file type. And inside this file type method, yeah, so that was used as the super class. So let me open it in Notepad++. Do not open ID because I don't want to open ID because it will, I guess, crush my computer now. If I open one more ID, yeah. So yeah, it has the, I guess it has the private constructor or not. Yeah, okay, I could define a private constructor. I guess I did not do it here, but it doesn't matter. Yeah. So basically, the idea is that here I had this factory method which actually returns the corresponding object. Yeah, if it's CSV, JSON, or XML based on the extension tag. Yeah, so there was the file name, then I got the extension, and based on the extension, I returned the corresponding object type to the actually from where this method is called. Yeah. So this is such there is such flexibility in factory methods. Yeah, no, it's not only about doing the upcasting. There are, but yeah, most of all, at least from my experience, this is not the only experience where I used the factory methods. But as I remember, in almost all the programming environments and all the programming languages where I used factory methods, almost, I guess not almost, but I think everywhere I used them to return the different types of the objects. Yeah. So that's the point. Using the factory method, one of the options what you can do is that you can get different object types. So is it at least this kind of usage, is it clear for you? If I'm not mistaken, that was Zana, or I'm not sure who asked this.
Yes, I asked it. Yes,
Okay.
thank you.
Yeah.
Okay, it was some
Yeah.
kind of example. Let's
Yeah.
see in that practice someday.
Yeah. Maybe, yeah. So if you program, if you do the programming, and if you use object-oriented programming, if it's C# or also Java or similar, I mean any object-oriented language you use, then at some point you may need to construct the. So one of the example could be, and this is also about yeah, so there's one more example also. Actually, that was from my experience. I don't have the code to show now, but maybe I have it on my computer. But I'm not sure if you understand this. This is some programming language you don't know. There is yeah. So on practice, we had the system, the software, which was used for multiple countries. So the software, there's the leasing project. Yeah, there was one leasing system which implements the leasing in 2 countries. So actually, no, there are 3 countries. It was Australia, Norway, and Netherlands. So, and let's say that, and for all these countries, there was one system which actually is used in all these countries. And then there was the process which I don't remember what was this process about, but that process actually there was some logic for that particular process. And like the logic for the using that may be some I don't know, some tax information to be filled in, some maybe pricing or something similar. And basically, what's the point is that for all these three different for these three countries, we had different logic, but I mean, we had the same interface. I mean, the user interface would be the same, and also the top of the program would also be the same. Like there will be one class. Yeah. Again, this is mostly about the inheritance. We'll talk later. But we had one class on the top here, which is the base class, and so then this base class could be different based on the country. So on practice, that means that for each country we created separate subclass. Yeah, one separate subclass, one subclass for Netherlands, one subclass for Norway, and one subclass for Australia. And for and yeah, so then when the interface is called, then this interface, yeah, actually the interface does not care about the country, does not care about the subclasses. The interface only cared about, like, here I am, I need to get the object with the type of this particular class, which is the base class, yeah, with the type of the base class, and then I need to call some methods and get some information. So this is also what the object-oriented programming is about. Here you can also see the abstraction. The main logic, the main interface, it only cares about the base class. Yeah, but the base class can actually have different instances and also have different types. I mean, the subclasses what can be there. And then yeah, so how could we proceed in such case? We cannot call the constructor. We can call the constructor, and we could not create the object directly from the base class, because it doesn't make sense. We need to have the object from one of the countries, from Netherlands, Norway, or Australia. Then what actually happened? We created the factory method, and then inside the factory method, we could determine the country. I mean, the current country, which is currently displayed for the user in the system. Yeah, actually, each user has the authorization. Yeah, for example, I'm authorized in the system, and I have the country assigned, what would be, let's say, Netherlands. And then, based on my user, the program can read the information about my user from the database, from the database, and then, yeah, program gets my country. Yeah, the country from where I am, so that the country is Netherlands, then it sees that I'm from Netherlands, and the factory methods, it creates the instance of the class, which is the subclass of the space class, which is talking about. But the subclass is created for Netherlands, so now we have the object which is needed for Netherlands. Then this object is returned back to the program, to the main program, and it is casted to the base class, and then all the necessary methods are called. Yeah. So get price, again, the base program will look simple, like call the method get maybe price, then call the method get tax, and all these cases. And these methods can be called from the base class, yeah, from the super class. And from that program, we don't care about if it's that's Australia, Netherlands, or Norway. Yeah, they all, I mean, for base class, these methods are the same. And then we have the factory method, which simply returns us the right object type. So this is where we can use it. But yeah, so I would say that it's mostly about the returning of the subclasses of the right subclass. So is it maybe this example also makes more clear for you? I mean, we'll talk about the inheritance. Yes, at this point we didn't go into the inheritance deep yet, but so when we talk about the inheritance, then this should be more clear. Yeah, but for now, for you just to know that such cases are possible. Such cases are possible, and this would be one of the options how we can how you can create the objects. Yeah.
I have a question,
Yeah.
a small one,
Yeah.
regarding small neons.
Yeah.
This factory method, as I understood, we write it down at the get instance, and I wanted to ask, this is only factory method, or is there other ones maybe?
I mean the pattern, the name. Of course, you can write your own name, since this is up to you. What kind of the name you write? From my experience, it is usually get instance. Sometimes it may be something different. Create a person, for example, it can be, or something similar. It depends, but that's the name. That's the name what you can write. Yeah, so that's the simple method. Yeah, actually, the pattern is that this is the method. Yeah, all the factory methods, they are usual methods. They are mostly they're static, but sometimes in also some special cases they can also be instance. But these are, I would say, these are more special cases. Yeah. So, but they are the methods. They are the methods, so you can call them as you want. You can define any pattern you want. This is up to you.
But then what defines this as factory method, that you use this, for example, there wouldn't be like public static person, for example, get a snowman name and return new person. And so our system.
That would, yeah, we can say that it's also factory method. So the idea of factory method is that it as it stands from the name, it is factory. It produces something. Yeah, so here it produces the, like in this case, it produces the persons, but yeah, it can also produce the snowmen, and this is actually, well, yeah.
So, but it's always return new person, yeah. So the like there should be in brackets.
Yeah, I mean, in such pattern, yes. So, for example, you can create different patterns. So, remember, yesterday we talked about passing by reference. So, let's say that I define. Hold on. Let's say that I define the person variable here. Then I define public static. Let's say that would be white, and then I pass person by reference, and then I simply assign the new person to the reference. Yeah, so then I call this get instance from the person. So get instance, and here I pass this person as the ref. Yeah, so remember what we did yesterday. So that would be the same. Yeah, so person, it's yeah. So what's going on here? Okay, it's unassigned. Okay, so maybe let's do it this way. Try. Yeah, so this is, actually it means nothing, but yeah, so we can also do it this way. Yeah. We can also do this. So again, the pattern can be different. It depends. So don't stick to the pattern. Yeah, never stick to the pattern, because the pattern of the program, patterns of the method, it can be different. Usually, again, as I just said, they are returning something, but there can be also some maybe more advanced patterns. Like here, we have pass by reference. So that would be the same as if I just simply return to the person, but so that's, I mean, that it depends on you how you define, on you or on those who do it. Yeah. So it can be different. So don't stick to the pattern. It can be something, but again, the key point is that we need to produce the object from the factory method. Yeah, this is why it is called. How do we return it? How do we define it? It depends on us, but yeah, at the end we have the object.
Thank you.
Yeah. So yeah, that's about it. Oh, yeah. So the question from Lena: why do we need to get and send method? In this case, we don't use them, but where do I have the age? No, yeah. we need to access name and age. So it means that I can access name, I can set, so that will be my, that's my name, Jack, and the age would be something like this. Yeah. So in that case, we need getters and setters to be able to set the name and the age of the person. Okay. This is why we need, because otherwise, if we simply do it this way, then we can't get and can't send the. No, so they are private. Yeah, okay. Since they are public, then in that case that will be the same. And yeah, in this case, yes, since they are public, there are actually no difference between them. That is correct. But for getters and setters, we can also write some logic. It's possible, but yeah, in this case, it is just the usual pattern. It's just the usual pattern that we can write. Yeah. Okay. So let's continue. So that was about the class constructors, and yeah. So the next step is encapsulation. I would also say, from some point of view, this is I won't say the synonym of abstraction, but the quite related. I'll say this is one of the concepts of abstraction. So it's encapsulation. So as I said, abstraction also means that we wrap something inside the object or something. Encapsulation, it is also what stands from the name. There's the capsule. We put something inside the capsule, so it means that we encapsulate something. Same as here. We have some data. We encapsulate it inside the object, and then there's the thing. Yeah. So what's the difference? Yeah, actually, the term encapsulation, also from my experience, maybe So just there. Regarding this term, there are some. I guess I watched some YouTubers long time ago. They were talking about encapsulation, and they were shouting that most people do not define encapsulation correctly. Yeah, like from the strict definition of encapsulation, there may be some special points there. Maybe let's not stick to them. The thing is that again, first of all, we wrap. Basically, what stands from the name? We wrap the data somewhere, and then yeah. So comparing to the abstraction in general, it is not defined if we can or cannot access the data. In the encapsulation, so when we put something inside the capsule, then in practice we may restrict the access to this capsule to be able to open this capsule. So the access to the capsule and to the content what is inside inside the capsule, it can also be restricted. So yeah, and here's the point. Using the encapsulation, we can hide and provide and restrict the access to something what we hide. So we combine the elements into a new entity. Yeah, this is true, and then we so we actually wrap the data and we can also, as I just said, define the hiding of the information and restrict the access. So let's talk about it in the further slides. So yeah, encapsulating a class means that the members of the class must always be declared with a minimal level of visibility. Yeah, actually, yeah. So again, on the top, think about the encapsulation as directly from the English term of view, and from the English point of view, like we have capsule, we have encapsulation, then we need to, it means that we encapsulate something inside. Yeah, and actually in different programming languages, yeah, this is why this term is quite tricky, because in different, yeah, so here we say with the minimum level of visibility. Okay, then for such programming languages like C#, C++, Java, and similar, level of visibility will be like the levels of visibility, they are the same in these programming languages, but there are some programming languages like Java where there is no such things like level of visibility. JavaScript. I think I said JavaScript. In JavaScript, there are no such things like visibility, level of visibility. So, but encapsulation is, I would say, still in place. So, need to be careful about the term encapsulation. So, yeah, the thing is that level of visibility. So, same as for the capsule, as I said, we do not allow everyone to only we have restricted access to the content of the members of the class. Yeah. So, and this is why we provide accessor mutators to allow getters and setters to allow control access to private data. Yeah. So, level of visibility. This is why we use private protected public or default, which means nothing. Using them, we define the level of visibility of our members. The members, again, can be the attributes and can also be the methods. Yeah, so using the access modifiers, we provide a control them. And yeah, so normally, as I said, members, as it said here, members of the class must be declared, usually they must be declared with the minimum level of visibility. So it means that the members are defined as normally defined as private. And then we can define some additional methods like getters and setters to then be able to control them, to be able to restrict the access to them, and to be able to do some validation. Yeah. So, for example, when we want to change the members, change the attributes, then we may have the situation when, let me check if the translation is still going. Yeah, I think because computer shows that I'm having some internet connection issues, but okay, the translation is still going, so that's fine. Yeah, so we are hiding the information, but the idea is that we restrict the access. Again, we can have the validation. So the validation can be, for example, when we define some attribute which can only have the range, like let's say that be integer, which has the range from 10 to 20, and then using the encapsulation, using getters and setters, you can make the validation that the user cannot set any value which is outside of the range. Yeah. Okay. This would be the point. this would be the point here. One moment. One moment. Yeah. Excuse me. Yeah. So that's why we define access modifiers. Then we have access modifier private, which means that we can only access the member of the class or member of the object from inside the object or the class, which means that we can also access these members from the subclass of the corresponding class or the object, and the public means that we can access from everywhere where the class or object is accessible from. Yeah. So, and as a possibility, there will be that the member can be the method and the attribute. So on practice, it is usually done in the way that the member, the method or the attribute is private or protected. Then again, I said we cannot access them directly, but we can have some additional, let's say, methods. We can have some additional methods inside the class which are defined as public. So it means that you, from your piece of code, then you define, you call the public method of the corresponding class. Then this method actually calls it accesses the private attribute, actually private member of the class, and this is the way how you interact with the private or protected members. Yeah, so you can do it through the public method. Yeah, so this this may be the option. Yeah, that basically the interaction happens through the public methods. So yeah, this may be the example that we define getters and setters. So what this would mean? So in this case, let's say, so that was asked by Lenin. Yeah, so let's say that we want to define the private attributes for name and surname. So let it be for name and age. So say that will be private name and also a private string name. And let's say that will be private age. So then, for these two methods, for these two, for getters and for getter and setter, we can define the logic which will return as, like for getters, these will return as the values of the attributes, and then for the setter, it will set the value. So it means that for getter, let's return the name, and then for set, I will set the value. Oh, sorry. Yeah, so for setter, that would be that I set this name from the value provided. Yeah. So, and in fact, inside this getter, I can write the name. Yeah, so for example, I can return not this name, but I can return, let's say, this name and then to uppercase, for example, to uppercase, to upper method. Yeah, so it will not return me the actual name, but it will actual text, but it will return me the text only in uppercase. Yeah, for example, that would be for setter. Let's say that I set the value, and let's say that I do some adjustments with the value. Let's say that I add some adjustment to the setter. Yeah, so for example, we can do some adjustments inside this name. Yeah, well, it's not correct. Question from Owen: is it correct to return this name? Okay, so yeah, that's because when we're working with the, yeah, you see, we don't have static. If we don't have static, it will always be instance. So it means that every method, like if it's getter and setter, or every member which is not static, it will always be the part of the object. So it means that the instance will be created. Yeah, this would be correct, since we are under the object. Yeah, so yeah, we can actually check this. What will happen? The method toString, we'll maybe talk about it a little bit later, but I prefer using it since this is overwrite, overwrite to string. So remember that's toString method that it is called to, it is created to describe the object as the text. Yeah, so I write the comments, describe the objects as the text. I will talk about it a little bit later, but for now I will start using it since I like using it. For example, I can describe it in the way that, say, I can describe it this way. Say name. This, this name and this age. Yeah, maybe I will some more descriptive. Oh, there's like new line and the age. This. So let's then describe the person. How our person looks like. Here it is. And let's run. I don't want to debug. That's what I know. Please run. Okay. And I can't run this. Can't see the button. That would be, sorry, that I guess that's the wrong one. Oh, or that's the right one. Okay, let's see. It's the right one or the wrong one. I need to select the second one, or let's see. Yeah, that was what we wrote yesterday. So let's select. Yeah, we can select executable from here. So I accidentally selected daemon, not today's daemon. So let's see what what will be shown. Yeah. So come back. Okay. Yeah. So you see that here we assigned the value Jack. Yeah. So despite the fact that we simply have this assignment, basically what happened, actually the setter was called. Yeah. So this is actually name is not the name of the variable. This is the name of the setter and getter. Yeah, so every time I access actually this element, instead of accessing the variable directly, we use this getter and setter, and then it has some special properties. So, for example, when we assign the value to this setter, yeah, actually then the setter is called. Yeah, so the setter is called, and it means that this logic is called. Yeah, so what this logic does, you see it directly here. It assigns the value we provide from setter, so it means that we provide right here from the right side, and yeah, then I can concatenate it with my additional text. That's why after this setter is called, then under the name there is this text stored. Yeah, so there's the text, the value, and then the addition from here. And yeah, so when so why I have here all the characters in uppercase, that's because here you see I called also this getter. Remember, I can call, if I have the public methods, and getters and setters, in this case they are public. Yeah, so it means that I can call these getters and setters from all the places in my code, also from outside the class. Then it means that when I access this getter, this is what I do here, then actually it returns this particular content here. So that's the name, and it is translated to uppercase. And this is why we see it in uppercase here. So basically I can write any logic I want here. So I can translate to uppercase, do any adjustments I want, and then display it from here. Yeah. So, and the H is also simple. If I don't have any special logic, I can simply write get and set, and then it will, in this case, a moment maybe. Yeah, you can do it this way, but let's maybe, so it's maybe more interesting. Let's return this H, and let's set this, so to not make it strange, let's just simply set it this way. So, and if you actually use the brackets, then you don't need yeah, of course, don't forget about semicolon. Okay, so now everything is fine. Yeah, and basically now H is stored under this particular variable, and yeah, I never use this. What's going on? Well, it says that it's never used. This used. Okay, then maybe it's just a glitch in the program, because it is used, and so here it is used. Okay, just a small glitch in the program. If I refresh them, this warning will disappear, because here I use them. Here I use this H. Yeah, so this is what the getters and setters are about. Yeah. So so some comments: property that provides access to the variable. Yeah. So we have this private member, private variable. Then I access it using the getters and setters. Can do some adjustments in between. Before I return some value, I can do some adjustments before I set the value. So we can do some validations and some adjustments if needed. Yeah, some property can be declared using declarations. Yeah, Knox access to specified executable statement associated with the reading and writing the property. Yeah, so the syntax would be that getters are, I mean, they are the logic is defined inside the brackets. So yeah, the accessor declaration consists of get accessor declaration and set or both. Yeah, this is the special syntax what is used in C#. Yeah, so for getters and setters there are such keywords. Like in other languages, for example, in Java, they're simply called as the methods. And actually in C# you can also use this approach. Instead of using these get set, you can define your own methods. Yeah, that will be public methods where you access these attributes directly. So that will be also as an option. If you want, you can use it. It's actually there's no difference if you use this approach or if you use just simple method approach. I mean, just define, let's say, get number method, getter or set number, setter, and use them. That would also be the option. Just up to you. No restrictions. Okay, so do you have any questions about these definitions? So yeah, one point, one usual example when I explain why the private members may be needed. Yeah, so for example, let's say that even if you don't have any special logic for the member, like here for name, I have a special logic that I add this string. Of course, there can be some other special behaviors for the setters. But even if you don't have, it's like if you simply just have get and set, it is always better to define the members as private. And then the question may be why. So it's always better to have it. And let me explain when this may be crucial. So let's say that you have the class, yeah, so some objects, the objects are created from this class in your program, in your software, in your application. And yeah, so there is the program, and then your code, your class is used, let's say, I would say in thousands of places from the application. Yeah, thousands programs, thousands files use your class and the attributes what are defined in that class. And let's say that your attributes store maybe name and surname, maybe name and surname. Yeah, name and surname, which is then filled from some place in the code. Yeah, don't care about from where it is called, and then your program takes these attributes, and at some point it calls maybe another program, which then passes these attributes, this data, I mean name, surname, for example, to the database. And let's say that at some point you have the requirement. You have the requirement which says that, for example, in some cases, some files, some programs cannot access cannot access this data, cannot access name or and surname. Yeah, so the access can be restricted. So before any program can access these attributes, there should be the authorization passed. Yeah, so like, I mean, let's say any random one of thousands programs, it calls, I mean, it tries to access your attribute from your class, and then because of maybe some authorization missings, then the program cannot access. There may be some exception or something similar. It depends. Yeah. So then you have this requirement. So let's say what happens if you have public attributes. In this case, in theory, means and like every class simply access these attributes directly. Every class in the program accessed these attributes directly. Yeah. So like simply they're public, so any program can access them directly. But now there's the requirement, there's the need that the access to them needs to be restricted. So what can be the solution for this? The only solution would be that that you need to actually make the changes in all these thousands files where these attributes are accessed from. Of course, this would be disaster for you because like then thousands of places need to be changed now. This is not good, right? So this is not good, and now this may be the problem. Or let's say the values. Yeah, if you set the values, then let's say that you have the requirement that now all the values must be set in uppercase for your class. Then the same issue, you need to make the changes in all these thousands programs to then thousands files from where your class is used, and then translates the values to uppercase there. Of course, again, that would also be a disaster because you need to change the same thing in thousands of places, and also that would be from Git perspective. Yeah, so from Git perspective, we need to change then thousands files. So again, what happens when we make the changes using Git? It means that we actually lock these. Again, if it's Git version control or any other version control, actually then normally the files are locked, because the idea is that normally only one person works on these files. Yes, so in this case, it means that when you work on the file, you actually lock these files so no one else can make the changes until you complete your changes, right? So in that case, if you need to make the changes in thousands of files, first of all, you may make the mistake. Again, that's obviously human mistakes are quite common in programming. That is fine. So there is the major possibility that at least in one of the thousands files you may make the mistake. This is one thing, and secondly, or maybe firstly, at first you will lock all these thousands files. Yes, so no one else can make the changes inside these files until you finish your adjustments. That would not be good, right? And yeah, on the other hand, let's say that we define initially at the beginning of the wall development, we define our we define our members, I mean name and surname, as private. So it means that every time when any program accesses these members, they are accessed using getters and setters. So what does it mean? It means that, like, again, let's say that now we have the requirement that all the values need to be set only in uppercase. So it simply means that you simply do the change in one setter, and that will be it. Yeah, you make the change in setter, and you're done. It's only one line of code, one file. No one else is blocked, and this will be fine. Yeah, so no one else is blocked. Yeah, also the same about getter. You can write the authorization check there, and then maybe raise some exception or simply return nothing. That would also be the option. Yeah, so this is about why do we need private attributes, and why it's always better to use private attributes, and then simply set them using getters and get and set them using getters and setters. Okay. Is it clear why do we need them? Do you have any questions? Okay, hope it's clear. And yeah, so in addition, also about related point, you usually ask me before why do we need to create the methods, and at some point you may also want to create the methods in separate files. That would also be the option. Like let's say you have the program, and then yeah, there may be such necessity to create new methods not only inside your file, but in other files. So for example, here I have I have one file, and let's say that's and yeah, why one great point, why it would be better to not store the multiple classes inside one file. Yeah, there's one significant advantage. This is also related to the version control. So for example, here you see I have one file. I have two classes inside this file. I have the class person and the class program. So basically, let's say that, I mean, of course, this is a small program and I'm the only one who's working on it, but let's say that you have a large program with lots of different files, and yeah, then you want to make some changes there. So in that case, let's say that we are inside a large project where there are lots of different files, folders, and so on, and then yeah, let's say that you need to make some changes in the person class. So what will happen when you use the version control? You will simply lock the whole class, the whole file. So it means that if you have multiple files inside one class, multiple files inside, what the hell I told you about? Multiple classes inside one file. Then it means that to make the changes in one of the class, you need to actually lock the whole file. Yes. So again, usually it means that when one developer works on one file, it simply locks the file, as I just said, and normally others do not make the changes there until the changes are done by this particular developer. So yeah, and in this case, why it is better to create separate file for the class is just simply to also encapsulate the code. Yeah, so the encapsulation of the code may also be crucial in the project because of the version control. And in that case, let's say that you have the class person located separately. So it means that you make the changes in your own file, in a separate file, and you don't touch other files. So other files will remain the same, but there may be some changes done there, but you don't lock other changes. You lock only your class, your person class. So I hope you understand why this may be important. Yeah, so then it's also better to encapsulate the code into separate files just because of the version control. And so you are more flexible to make the changes. Yeah, so for example, in the environment I'm working in, there are the classes, there are the methods, and usually the version control is built not only on the classes, not only on the files, but also on the method level. So it means that the methods separately can be transported. Yeah, so there is such feature, and in fact, there's the so-called transport system, which transports the methods separately. Yeah, not the whole class, but methods can be transported from one system to another. And yeah, that is why in my system, in the system I'm working in, it is better to create a separate method. So if in case we need to do some adjustments, we touch only the exact method. Yeah, we make the changes only in exact method, and other files, other objects are not affected. Yeah, so this is why it is better to encapsulate. Encapsulate, we can call it the code in separate files as well. Okay, so do you have any questions about this? Okay, so then let's continue. And getters and setters are clear for you now. Then, yeah, this is what we can call what let's say the encapsulation is about. But how we can one of the ways how we can explain the encapsulation. So it means that we encapsulate these members inside the object, yeah, and we don't allow them to be accessed directly from outside the class. Yeah, we need to, let's say, ask permission or ask for validation or something similar before these members are accessed in one or another way from outside the class. Yeah, so we can control the accessibility to these members. Okay. And so you can, yeah. So in such case, we have a simplified syntax in C#. Yeah, so instead of defining separate variables, we can actually, this can be done in the way that simply have such syntax. Yeah, so that will be equivalent, but just a shorter one. And comparing to this syntax, here you can't write some special logic, yeah, under get and set. So here you just only have such keywords, get and set. But yeah, regarding the example I just explained to you, so if we have such pattern, then what will happen? We can define private attribute number, then we can enhance at any point. We can enhance these two attributes, not the attributes, these two getter and setter. We can enhance them as we want, and yeah, then apply the changes. So I just got the notification that the streaming is okay. Sorry, connection successful. Yeah. So yeah, this is for the static members. Members can be static members. We can operate with them at any point if we have the access to the class. And so if we have the access to the class, then we can operate with the static members. Yeah, so actually, yeah, the static attributes, we can consider them as I said, as they belong to the class. So it means that we can only deal with them when we access the class. For comparing to non-static attributes, we can deal with them if we access the corresponding object. Read-only, as we just seen today, they can be accessed, not the access, they can be changed only inside the constructor. Yeah. So like usually it's only one time. There's one additional modifier which is called volatile, yeah, that can be modified in the program by something like the operating system. Yeah, so it means that we do not define it. Sealed means that cannot be inherited. External indicates that the method is implemented externally. Also, get our points may not be needed. Okay, let's take a look on the last part today. We'll go through the recent slides once again on Monday, so don't worry. Then there's virtual declare method, and after the implementation can only be changed by an overriding method in derivative class. So yeah, okay, maybe about the virtuals I'll maybe explain it also better when I have more time than on Monday. And yeah, the overriding means it is used for the inheritance. Yeah, when we inherit the methods, then we can override them. We can change the behavior of them. And basically, this is why we need virtual methods. So it means that we can override them, because if we don't use virtual modifier, then we cannot override it in the subclass. Yeah. So yeah, basically this is what the override access modifier is about. We will go through these access modifiers again later, since some of them are directly related to the topics we'll talk about next. Yeah, so we'll go back to them later on. All right. Do you have any questions? Yeah, remember that as we discussed, we will move our Saturday session to next Saturday, because again, it's working day officially in Latvia this Saturday. That's why I assume some of you may work this day, so that would be a little bit unfair if any one of you cannot join the session because of the fact that this is working day officially in Latvia. So then we can move it to next Saturday. In addition, we don't have a session on next Thursday because of the public holiday. So just to not have the long gap, we can fill it in with the Saturday session. Yeah. So, and yeah, on Monday, as I said, there will be the small knowledge check about the topics we gone through. So yeah, so this will be on Monday. Do you have any questions? Okay, so if there are no questions, I wish you all a nice Friday, nice weekend. Please complete activity 1 and activity, theory. I guess, Eleni, you were not attending previous session. Yeah, I understand. There will be the knowledge check, like the test with you'll have theory questions, and there you will have the options to select. And just a small knowledge check, so you can refresh your knowledge this way. And this will be on Monday. I will somewhere at the middle of the session, so just not make it at the beginning. Somewhere at the middle of the session, I'll give you the test, and you can complete it until the end of the day. You can submit it. Yeah. This would be the theory tests about the topics we come through right now, this week and last week. I will share this presentation with you, and I will also then, as usually, I will push the changes into the remote repository, the code into the remote repository, so you can take a look on it as well. Okay, but in case you have any questions, you can reach me today